Welcome back to the problem solving series with one. Today we're working on question 5. This one is interesting because it combines the quotient rule, product rule, and chain rule all in one function. So let's dive in. So what does this problem state? In this question, we are asked to differentiate this function with respect to x. First of all, notice it is a fraction. And what does this tell us? This means quotient rule will be needed. But if you look clearly at the numerator in itself is a product of two different functions. So what does this tell us? The product rule will also appear. So we're going to layer our differentiation rules carefully. So let's start. First of all, for my first observation, this question is a fraction, which tells us that the quotient rule is going to be needed. Recalling our quotient rule, our first step was to identify our numerator function and our denominator function. So what are we first going to say? We'll call our numerator function f of x. That is, let f of x be equal to our numerator function x squared plus 3 sine of x. And we're going to call our denominator function g of x. Let g of x be the function e to the x. Recalling our quotient rule, it states that the derivative with respect to x of any function of the form f of x on g of x is bottom d top minus top d bottom all over bottom squared. So in this question, or in this expression, there are three different terms we need to find. Our first term is the product g of x and f prime of x. Our second term is the product f of x and g prime of x. And our third term is the square root of g of x. So let's start with our first product. In this our first product, we already know our first term g of x. The remaining term is f prime of x. So let's find f prime of x. First of all, we call f of x. F of x is the function x squared plus 3 times sine of x. If we notice this function, we notice that this function can still be represented as a product of two functions. That is, we can say let the function u be equal to x squared plus 3 and v be equal to sine of x. Now we notice that f of x can still be represented as uv, which is the product of two functions, and this implies that the differential with respect to x of f of x, which is the differential with respect to x of our product uv, is equal to u dv plus v du, right? So in this term, still in this expression, we have two terms here, u dv and v du. But in our first term u dv, we don't yet know dv, and in our second term v du, we don't yet know du, which is same thing as u prime. So let's first of all find those terms. U prime is equal to the derivative with respect to x of u, which is the derivative with respect to x of x squared plus 3, and this gives us the derivative with respect to x of x squared plus the derivative with respect to x of 3. This is the application of our sum rule, which tells us that the differential of a sum is same thing as a sum of their differentials. So let's move on to this. Recall, what method can we apply to differentiate x squared? The method we can apply is the power rule. So derivative with respect to x of x squared is same thing as 2x to the power 2 minus 1, which gives us 2x. Let's move on to the next term. Derivative with respect to x of 3 gives us 1. Why does it give us 1? Because 3 is a constant, and recalling our constant rule, it states that the derivative with respect to x of any constant is 0. Is 0, sorry, Jesus, I wrote 1. Is 0. Is 0. Yes, so the derivative of any constant is 0. So let's move on. Replacing these terms In our initial expression here, we have the derivative with respect to x of uv is going to give us u. What is u? X squared plus 3 dv. What is dv? dv is I've not calculated it. Oh guys, sorry. V prime, which is the derivative with respect to x of our term v, which is the derivative with respect to x, and what's our v? Sine x, gives us, if we recall very well from when we were working on trigonometric functions, it was well stated that the derivative with respect to x of the trigonometric function sine x gives us the function cos x. So we're just going to replace this here. What is dv? Cos x plus what is v? Sine x, and what is du? Du is this plus this, which is 2x plus 0, 2x plus 0. So this gives us cos x into x squared plus 3 plus 2x sine x. So what can we then conclude? Therefore, the derivative with respect to x of our function f of x, which is the derivative with respect to x of uv, which is f prime of x, is equal to the function x squared plus 3 cos of x plus 2x sine of x. So we have found our f prime. Now let's move on to g prime of x. First of all, we need to recall our g of x, and our g of x is the function e of x. So this tells us that the derivative with respect to x of our g of x, which is same thing as g prime of x, which is the derivative with respect to x of our e of x, is, now we then need to recall the derivative of exponential functions, and it was well stated that the derivative of the function e of x is e of x. That means it remains unchanged. So this gives us e of x. This concept or this response was well proven when we were working on the derivative or the differentiation of exponential functions. So in order, if you don't understand this derivative, you can quickly review the video on the derivative of exponential functions and come back to this video. So let's continue. This implies that our g prime of x gives us e of x. So now we have our g prime of x, we have g of x, we have our f prime of x, we have f of x. So what do? We replace in this formula. Sorry, we don't yet have g squared. Let's calculate it first. Now g of x, all that squared, gives us e of x squared, which gives us e to the 2x. So now that we have all the terms, we can simply replace it in the function. We notice that the derivative with respect to x of our function y is same thing as bottom the top minus top the bottom on bottom squared. Let's rewrite our functions. We notice that g of x is the function e of x, g prime of x is e to the x, g of x all that squared is the function e to the 2x, f of x is the function x squared plus 3 times sine of x, and f prime of x is the function x squared plus 3 of cos of x plus 2x of sine of x. X squared plus 3 of cos of x plus 2x of sine of x. So we can then substitute. This implies that the derivative with respect to x of our function y gives us g of x times f prime of x squared plus 3 cos x plus 2x sine x. minus f of x squared plus 3 sine x times g of x e to the x, all that divided by e to the 2x. So what we can notice in these two terms is we have e of x common on both sides. So this gives us e to the x in bracket x squared plus 3 cos of x plus 2x sine of x minus x squared plus 3 sine of x, or divided by e2x, which is e of x times e of x. One e of x can cancel one of them, leaving us with, we then simplify this, we have x squared plus 3 into cos of x plus 2x sine x minus x squared plus 3 sine x, or divided by e of x. Now if we look closely to our numerator, we notice that there still exist two terms which are common, that is this term and this term, which have sine x in common. So we can factorize out sine x in both of these terms, leaving us with x squared plus 3 cos x plus sine x into 2x minus x squared minus 3. So this leaves us with, all divided by a of x, leaving us with x squared plus 3 cos x minus, we can still remove it out, x squared minus 2x plus 3 into sine of x, all divided by e to the x. So what do we observe? We observe that after replacing our terms and simplifying, we're able to obtain this function, which is the derivative with respect to x of our function y. So in conclusion, that is, therefore, the derivative with respect to x of our initial function x squared plus 3 sine x divided by e to the x gives us, which is same thing as dy on the x, gives us the function x squared plus 3 cos of x minus x squared minus 2x plus 3 into sine x, all divided by e to the x. We enclose or box our answers. So that's the derivative of our function. Notice how we combine quotient rule with product rule in the numerator, then simplify it carefully. This is exactly the kind of problem that strengthens your differentiation techniques. So in the next video, we'll explore another layered function. Stay tuned. Thanks for watching this video. Bye.